Today's cosmology can hardly be imagined without the Big Bang. Everything seems to revolve around the moment when all matter was suddenly created out of nothingness. This mysterious origin of the universe is discussed in countless popular science articles across all media. Scientists all over the world are busy devising experiments to shed light on the dark depths of the cosmos. In their search, they have visions of strange things like neutron stars, dark matter, and dark energy. They tell stories of alien worlds where the known laws of physics do not apply. This film takes a different approach. It's a path less traveled on which we do not encounter pseudo-objects like all-devouring black holes at the heart of galaxies. But still, it offers surprising and fascinating insights. We will travel back in time to the moment when the idea of an expanding universe, and thus the Big Bang, was born. We will see that modern cosmological theories do not necessarily follow from the observations of the 20th century, and that there are alternative models. We will learn to see the processes in the universe in a completely new way. Because this is the story of an all-electric cosmos. A cosmos without a Big Bang. The year was 1929. The American astronomer Edwin Hubble had just published his soon-to-be famous article describing a linear relationship between redshift and distance for galaxies. But what does that mean specifically? Due to the enormous distances between stars, and especially between galaxies, we cannot study these objects on sight. We rely on the light that reaches us from there to obtain information about such distant objects. Fortunately, the night sky provides us with an abundance of information. It is the task of astronomers to collect this data. The task of cosmologists is subsequently to organize and interpret the collected data according to their own judgments and theories. A powerful way of obtaining information from the light of distant galaxies is provided by spectroscopic analysis, which splits up light into its individual wavelengths. For our Sun, the spectrum looks like this. The black lines are absorption lines. This means that certain wavelengths of light are absorbed by certain molecules in the Sun's atmosphere. The same lines can also be found in the spectra of galaxies. However, the peculiar thing is that the black lines in distant galaxies are shifted compared to the Sun, towards the red, less energetic part of the spectrum. This shift can be expressed in percentages. If this line is at a wavelength of 500 nanometers, and the corresponding line in this spectrum is at 510 nanometers, it is a 2% redshift. The opposite, a blue shift, is observed in rare cases. Here we see a blue shift of 2%. For instance, the light from our great cosmic neighbor, the Andromeda galaxy, is blue shifted. But the majority of galaxies appears redshifted to us. This is, thus, the pure astronomical observation. These are the pieces of information that have found their way from the galaxies into the lenses of our telescopes and the prisms of our spectrometers. Now, in 1930, the cosmological interpretation of this astronomical observation was in full swing. One interpretation that was quickly applied, even by Hubble himself, was the so-called Doppler interpretation. We all know a Doppler shift from sound. For example, when a car approaches us, the sound of its engine becomes higher at first. The sound waves are compressed. When it has passed us, the sound becomes lower as the sound waves are stretched. In a similar way, most cosmologists interpreted the redshift of light as a Doppler shift related to the motions of galaxies. The Austrian physicist Christian Doppler had already predicted such a redshift due to the motion of the light source in 1842. The percentage shift of the absorption lines in the spectrum was thus interpreted as a velocity. A shift of 2%, for example, means a velocity that corresponds to 2% of the speed of light. That's about 6,000 kilometers per second. According to this interpretation, it appeared that all redshifted galaxies were moving away from us. And that wasn't all. Hubble's diagram also suggested that the velocity of galaxies increased with distance. A galaxy twice as far away seemed to have double the escape velocity. In other words, interpreting the redshift as a Doppler shift directly led to the assumption of an expanding universe. In 1929, Hubble himself applied the Doppler interpretation to his famous diagram, plotting the redshift as a velocity on the y-axis. however, he cautioned and wrote,
"This explanation interprets redshifts as Doppler effects, that is to say, as velocity shifts indicating actual motion of recession. It may be stated with some confidence that redshifts are velocity shifts, or else they represent some hitherto unrecognized principle in physics. Meanwhile, redshifts may be expressed on a scale of velocities as a matter of convenience. They behave as velocity shifts behave, and they are very simply represented on the same familiar scale, regardless of the ultimate interpretation. The term apparent velocity may be used in carefully considered statements, and the adjective always implied where it is omitted in general usage."
Most cosmologists at the time did not heed this cautionary advice for interpreting the redshift as a velocity. They quickly forgot that the adjective apparent needed to be included. Albert Einstein's general theory of relativity had just gained popularity, and one of its predictions was an expanding universe. The Catholic priest George Lemaitre had already attempted to reconcile his Christian faith with the theory of relativity in 1927 and subsequently developed the first version of the Big Bang theory. Lemaitre and other proponents of an expanding universe considered Hubble's discovery as conclusive evidence. All caution regarding the interpretation of redshift as velocity was disregarded. Hubble himself never jumped on the bandwagon. His common sense resisted the idea of an expanding universe. Today we can say that he made the mistake of not plotting the redshift as a percentage shift of absorption lines on his diagram, but rather as a velocity, and without the adjective apparent. This oversight haunted him for the rest of his professional life. Until his death in 1953, he steadfastly refused to interpret the redshift as a Doppler shift. But what other interpretation was possible? The Swiss physicist and astronomer Fritz Zwicky offered an alternative interpretation right after Hubble's famous 1929 article. In his hypothesis, light from distant galaxies loses energy on its way to us, leading to a real physical attenuation, a true redshift. This is known as the theory of tired light. Several possible processes were proposed over the years, ranging from Zwicky's gravitational friction to the Compton effect and Bremsstrahlung. In the 1930s and 1940s, Hubble himself conducted further observations to answer the question of which interpretation was correct. In 1942, he arrived at the following conclusion.
"Well, perhaps the nebulae are all receding in this peculiar manner, but the notion is rather startling. The cautious observer naturally examines other possibilities before accepting the proposition, even as a working hypothesis. Light may lose energy during its journey through space, but if so, we do not yet know how the loss can be explained. The alternative interpretation of redshifts as velocity shifts leads to a particular type of an expanding universe which is disconcertingly young, small, and dense. Moreover, the strange features of this universe are merely the dimming effects of recession expressed in other terms. Under these circumstances, the inclusion of the dimming factors seems to be a questionable procedure. In other words, the empirical evidence now available does not favor the interpretation of redshifts as velocity shifts. On the basis of the evidence now available, a choice seems to be presented, as once before in the days of Copernicus, between a small, finite universe and a sensibly infinite universe plus a new principle of nature, and as before, the choice may be determined by the attribute of simplicity.
His objection, along with that of other leading physicists, like Robert Millikan, was largely ignored by the majority of Big Bang proponents. Today, you can read the following about the theory of tired light, for example, on the German Wikipedia. The theory of tired light is an obsolete theory that explains the cosmological redshift observed in distant celestial bodies as a result of light losing energy on its way from the source to the observer. This theory has been abandoned in favor of the expansion of spacetime according to the general theory of relativity. The discoverer of the cosmological redshift saw it quite differently. Hubble deemed the Doppler interpretation, and thus the mathematical models of an expanding spacetime, fundamentally incorrect. Therefore, we are faced with two possible ways of interpreting the data. Unlike the majority of modern cosmologists, we will embark on the adventure of following Hubble's views. What observations support his interpretation, and where do we end up if we interpret the redshift as a physical attenuation of light rather than a velocity?